Hello friends, welcome back. Let's look at this example. We are solving problems as part of standard limits in limits. If x to the power of n minus 2 to the power of n by x minus 2 equal to 192, find the value of n. So to solve this, we know that I have to say here limit and x tends to 2. If limit x tends to 2, x to the power of n minus 2 to the power of n by x minus 2 equal to 192, find the value of n. So what I will do now is, I know the formula x to the power of n minus a to the power of n by x minus a, limit of this as x tends to a is nothing but equal to n into a to the power of n minus 1. So what is the value of n here? N is n only, a is nothing but equal to 2. A equal to 2, n equal to n. So if I substitute in the formula, this limit is nothing but equal to n into a, that is 2 to the power of n minus 1, that should be equal to 192. Now we will go by trial and error and see what are the values of n which will satisfy this. So for that, what we will do, we know that we have to multiply 2 to the power of positive integer multiplied with the power plus 1 to get 192. So what we will do, we will check all the values of 2 power n, will check all the values of 2 power n minus 1 n, and we will product them and see which one will match. So first let's start with n equal to 2, then n equal to 3, 4, 5, 6, 7. 2 power n minus 2, 2 power n minus 1, that's nothing but equal to 2. 2 power n minus 1, here it's equal to 4. If n is 4, 2 cube is equal to 8. If n is 5, 2 power 4 is nothing but equal to 16. If n is 6, 2 power 5 equal to 32. If n is 7, 2 power 6 equal to 64. Now we have to just multiply and see which one will satisfy. This is 2 2s are 4. This is 3 into 4, 12. We are multiplying 2 power n minus 1 with n, so that we will get n into 2 to the power of n minus 1. So the next one will be 4 into 8, 32. The next one will be 80, 5 into 16. Next one you can see 6 into 32, 192. So n is nothing but equal to 6. So immediately we'll go ahead and write this as 6 into 2 power, can I write it as, let me just go back, I will say n into 2 to the power of n minus 1 is nothing but equal to 6 into 2 power 5, that's equal to 6 into 2 power 6 minus 1. Therefore n is equal to 6. So it's a trial and error method by which we can solve this. Let's do one more example. Let's look at this one. Limit x tends to 1, x to the power of 15 minus 1 divided by x to the power of 10 minus 1. So if you just observe carefully, I can write this as 1 to the power of 15, I can write it as 1 to the power of 10. So we are able to convert that into limit x to the power of 1, x tends to 1, x to the power of 15 minus 1 to the power of 15 divided by x to the power of 10 minus 1 to the power of 10. Now you can see that these are nothing but x to the power of n minus a to the power of n with missing x minus a. What is x minus a in both of them? A equal to 1. So I have x minus 1. So I can write it as divided by x minus 1. Now this is nothing but equal to, I can separate them individual and I can say limit x tends to 1. So the numerator is nothing but x to the power of 15 minus 1 to the power of 15 by x minus 1 divided by, again limit x tends to 1, I will have x to the power of 10 minus 1 to the power of 10 by x minus 1. Now we know the formula. Here n is equal to 15. Here n is equal to 10. So we can substitute in the formula and write it as n into a to the power of n minus 1. 15 into 1 to the power of 15 minus 1 divided by 10 into 1 to the power of 10 minus 1. That's nothing but equal to 15 by 10, or which is nothing but equal to 3 by 2, because 5 2s and 5 3s. So what we have done? We have rearranged the given problem in such a way that we will get this into the form of x to the power of n minus a to the power of n. X minus a is missing, but x minus a is same in both, so it will cancel out. Now we can separate them and we can find out, apply the formula on that, and we can get the value. One more we do. Let us look at this problem. We have been given limit x tends to 4, x cube minus 64 by x square minus 16. I will convert this as limit x tends to 4. This should be in the form of x to the power of n minus a to the power of n. So I will write it as x cube minus 4 cube, which is perfect because x to the power of n minus a to the power of n. Similarly, in the denominator also, I can write it as x square minus 4 square. Now you can see that you have x to the power of n minus a to the power of n term, but we don't have the x minus a term, which is missing. So we will add that term in both numerator and denominator. We will make it as x cube minus 4 cube divided by x minus 4. Similarly, in the denominator we will have x square minus 4 square divided by x minus 4. But this is nothing but equal to limit. We can have individual limits now. I can say limit x tends to 4, x cube minus 4 cube by x minus 4 divided by limit x tends to 4. I can have x square minus 4 square divided by x minus 4. Now if we substitute in the formula, we know the formula is n into a to the power of n minus 1. So n is equal to 2 here and 3 here. If I take numerator, this is nothing but equal to n 3 into a is nothing but 4 to the power of n minus 1, that is 3 into 4 to the power of 3 into 4 to the power of 3 minus 1 divided by 2 into 4 to the power of 2 minus 1. So this is nothing but equal to 3 into 4 square divided by 2 into 4. That's nothing but equal to 3 by 2 into 16 by 4, which is nothing but equal to 4 times I can cancel, 2 times I will get 6. So the answer for limit x tends to 4, x cube minus 64 by x square minus 16 is nothing but equal to 6. So we have converted that into x to the power of n minus a to the power of n form, and we have divided by x minus a, so that we manipulated it such that we can apply the formula and we can get the value of that. We will do one more example. Let us look at this one. Limit x tends to minus 1 by 2. We have to find out 8x cube plus 1 divided by 2x plus 1. Now the formula we know is x tends to a limit of x to the power of n minus a to the power of n by x minus a is equal to n a to the power of n minus 1. N into a to the power of n minus 1. But in the problem we don't see minus, we see plus. So I have to somehow convert this into this particular format, x to the power of n minus a to the power of n by x minus a. But I have a hint here which tells me x tends to minus 1 by 2. Now what's the meaning of that? X tends to minus 1 by 2. We know from the formula that a equal to minus 1 by 2. That means I have to convert this into the form of x to the power of n minus a to the power of n by x minus a, where a equal to minus 1 by 2. For that what I will do? First I will try to convert 8x cube plus 1 into the form of x to the power of n, so that I can take out the 8 and I can get it in the form of x to the power of n. So what I will do for that, next step will be, I will take 8 out from the numerator. I will have x cube plus 1 by 8. You will agree with me on that. Similarly, I can take 2 here. I will get x plus 1 by 2. Now, if you observe carefully, this is nothing but equal to limit x tends to minus 1 by 2. 8 by 2 is 4 into, I can write this as x cube minus 1 by 8. Similarly, I can write the denominator as x minus of minus 1 by 2. So this is nothing but equal to limit x tends to minus 1 by 2, x cube we have 4 into x cube minus I'll put a flower bracket, minus 1 by 2 whole cube divided by x minus of minus 1 by 2. Now you can see that we are in the form of x to the power of n minus a to the power of n by x minus a, where n equal to 3 and a equal to minus 1 by 2. So for us to solve this problem, the hint we have to take is x tends to a. That means I have to convert this into the form of x to the power of n minus a to the power of n. For that I have taken 8 and 2 common and we have simplified it. Now this is pretty simple. So I can directly write it as limit x tends to, I don't need actually limit x tends to because I know the formula. So I'll write it as 4 into, now what's the value of n here? X to the power of n minus a to the power of n, where n equal to 3, a equal to minus 1 by 2. So let us substitute that here. We will have 4 into n into 3 into a to the power of n minus 1, that is minus 1 by 2 whole to the power of 3 minus 1. If I simplify that, that's nothing but 4 into 3 into minus 1 by 2 whole square, that's equal to 4 into 3 into 1 by 4, which is nothing but equal to 3. So the answer for this is nothing but equal to 3. What we have done is, we have seen that this particular problem is not in the format directly. We have to somehow convert that. To transform that, we have first tried to get into the form of x to the power of n. After that, we have find out a is minus 1 by 2. So we have written it as x to the power of n minus a to the power of n by x minus a, where n is 3, a equal to minus 1 by 2. Now once you simplify that, you can see that the value is nothing but equal to 3. We will solve one more example. Let's look at this problem. We have, if limit x tends to a, x to the power of 5 minus a to the power of 5 by x minus a is equal to limit x tends to 1, x to the power of 80 minus 1 divided by x minus 1. Both of them are equal. Find the value of a. So for that we will find out the limit separately and we will equate them. So first I will go ahead with the left hand side. This is nothing but equal to limit x tends to a, x to the power of 5 minus a to the power of 5 by x minus a, which is nothing but equal to n into a to the power of n minus 4. So I can say 5 into a to the power of 5 minus 1. If I take the right hand side, I will have limit x tends to 1. This is nothing but equal to x to the power of n minus, I have the flexibility of writing 1 to the power of 80 because 1 to the power of anything is equal to 1 only. So that I can transform that into the formula x to the power of n minus a to the power of n by x minus a. Now this is nothing but equal to n, that is 80, into a 1 to the power of n minus 1. Now if we equate these two, let me just take it out, 1 to the power of 80 minus 1, that is equal to 80. So if you equate this, you will have 5 into a to the power of 4 equal to 80. That will give you a to the power of 4 equal to 16. That will give you a equal to plus or minus 2. Because 2 to the power of 4 is 16 and even power, even the negative integer also, to the power of even power is positive. So you will have plus 2 to the power of 4 or minus 2 to the power of 4. So the answer is a equal to plus or minus 2. We will solve one more example. Let us look at this last example. Limit x tends to 0, cube root of 1 plus x minus of cube root of 1 minus x by x. What is the value of that? Okay. Now we want to convert this into the form of x to the power of n minus a to the power of n by x minus a, limit as x tends to a. So we'll just rewrite this and say limit x tends to 0. Can I say this as 1 plus x whole to the power of 1 by 3 minus of 1 minus x whole to the power of 1 by 3 by x. If you see, the numerator is in the form of x to the power of, the numerator is in the form of x to the power of n minus a to the power of n. It's in the form of x to the power of n minus a to the power of m n. Here we have to get x minus a. We don't have it. So let us try to manipulate this and write it down in such a way that we can get it into the formula. Now what is our x here? X is nothing but 1 plus x. What is our a? A is nothing but equal to 1 minus x. What should be x minus a? X minus a is nothing but 1 plus x minus of 1 minus x. That is equal to 1 plus x minus 1 plus x. That's equal to 2x. That means if I have 2x, I can write it as in the form of x minus a. I hope you are able to follow that. What we are saying? We are saying that we have x to the power of n minus a to the power of n, but we don't have x minus a term. So we are trying to understand what is our x? 1 plus x. What is the a value? 1 minus x. So what should be here at the denominator so that I can apply the formula equal to n into a to the power of n minus 1. So to do that, I should have 2x value. But what I have now currently? X value. So let me just try to manipulate it. I will say limit x tends to 0. This is nothing but equal to 1 plus x whole to the power of 1 by 3 minus 1 minus x whole to the power of 1 by 3. I will first write down whatever is needed. I will put the x here. I will put the x whatever I have here and I will write down what I need to have. I need to have 1 plus x minus of 1 minus x. And so what I have done is I have written it in the form of x to the power of n minus a to the power of n by x minus a into 1 by x, whatever is given. But I should multiply with this term because I am dividing with the term. What is this value? Nothing but 2x. We know that. So x will cancel. This is nothing but equal to limit x tends to 0, 2 into I have 1 plus x whole to the power of 1 by 3 minus 1 minus x whole to the power of 1 by 3 divided by 1 plus x minus of 1 minus x. So now if I apply the formula, I will have limit x tends to 0. This is nothing but 2 into 1 by 3 into 1 minus x n into a to the power of n minus 1, that is 1 by 3 minus 1. But x is equal to 0. If you substitute that, you will have 2 by 3 into 1 power minus 2 by 3, which is nothing but equal to 2 by 3. So one thing we have to understand is, if you see here, a, we always said x tends to a. Now what is our a here? Our a is 1 minus x. So 1 minus x, the formula we know is x to the power of n minus a to the power of n by x minus a is nothing but equal to n into a to the power of n minus 1 as x tends to a. But if you observe, we are writing here x tends to 0. We have to understand that why we have taken it like that. For that, let's write it here. Now the formula says x tends to a. What is our x here? 1 plus x. 1 plus x tends to a. A is nothing but 1 minus x. Now this is nothing but equal to, if you add x on both sides, it will become 2x plus 1 tends to 1 or 2x tends to 0. If 2x tends to 0, x tends to 0. That is why we have written x tends to 0, but this is nothing but actually equal to 1 plus x tends to 1 minus x, because that is what we should have in the formula x tends to a. I hope you are okay with that. So let's just summarize this. We have been given, that's the intermediate level problem, 1 plus x whole to the power of 1 by 3, 1 minus x whole to the power of 1 by 3. We see x to the power of n and a power n, but x minus a term is missing. So we have straightforward written x minus a term as it is. We checked that its value is nothing but equal to 2x. So when I divide, I should also multiply. And this is the 1 by x what is given to us. Now you will see that we have only 2, other than that remaining all are in the form of x to the power of n minus a to the power of n by x minus a. So simplify that, we will get answer equal to 2 by 3. One point to understand is, when x tends to 0, how can I do this problem? Because I know that x to the power of n minus a to the power of n by x minus a as x tends to a. But here it is given as x tends to 0. But to understand that, it is nothing but equal to 1 plus x tends to 1 minus x, because if you simplify that, you will get x tends to 0. So that's how we can do some problems in limits, and especially with respect to the standard result x tends to a, x to the power of n minus a to the power of n by x minus a. You can do so many problems like this, but just remember the concept. We always have to convert that into the form of x to the power of n minus a to the power of n by x minus a. Whatever is given after that, we can directly write it down as n into a to the power of n minus 1. So thanks for your time. In the next session, we will look into some other standard results as parts of limits, differentiation, calculus. Bye for now.